I guess more people need to come in, then only we'll get the accurate results, I think.
Yeah. When everybody comes, like before we start,
Yeah.
we'll again ask them.
Yeah, then we'll ask again.
Yeah, cool.
So, hello everyone. So I am Adil Mohammed. I am part of SQIL. So today in this electronics workshop, we have the electronics club from IIT Madras as who are conducting this program. So let's welcome electronic club members. So we have Sanjeev, Swati, Anish. So let us welcome the all.
Hello everyone. Welcome to the session. Before we begin with the session, I would just like to know how many of you have the kit with you right now. If you guys could just type an yes in the box, yes in the chat box, it would be great, so that we can know what content to cover and how much to do. Or if you guys could raise your hands also, that will be okay. Okay, so wait, Akhil, do you have the kit? Yeah, no, if you don't have the components, you don't need to direct message me. If you have the components, just put it in the chat. That's all. Okay. No, don't lower your hands. I just want to know how many of you have. So wait, I think 3 people have. Okay. Uh, okay. So only like 4 of you have the kit, like with the Arduino board. Few people texted me that they have the breadboard wires and bulb, but not the Arduino board. Yeah, that's fine. Okay. So since only a few of you have the board, we will be. We will be teaching you using Tinkercad, and also for people with the board, we'll also be teaching you how to implement it on the board as well. But yeah, all the basic coding will come from Tinkercad only. So people who don't have the board need not worry. Now let's start with the session. Anish will start us off with the session. I'll just share my screen. I'll just share the presentation.
Yeah. Hey everyone, this is Anish. I'm a coordinator of electronics lab C5, IITM. Okay. Hope you had lunch and are not sleepy. Okay. Okay. Bye.
Is my screen visible?
Yeah, it's visible.
Yes, sir.
Yeah.
Yeah.
All right. Okay. So welcome to this workshop. Welcome to electronics prototyping workshop. Okay. Next lesson. Okay, before we start off, let's start with precautionary measures which we have to take when we are using hardware components, because everyone is new to that, and it's very important so that the components do not get spoiled or you don't get affected due to electric shocks and all. So please follow these. Uh, yeah, please ground yourself to touch a metal which is grounded before before you start working with the board and all the components. See, okay, on the board there is a VCC pin, which is the power supply pin, and VCC or VIN, they are the power supply pin, and ground, there is also ground pin. Sorry. Yeah. So okay, never connect both VCC and ground pins. If you do that, it will short the circuit and your board will get spoiled. So never do that. Also, never keep your area dry. Never touch with wet hands and all, because water is a good conductor of electricity, and yeah, the components may get spoiled, or you may even get shocked or something. And they're very delicate. The components, the resistors, the LEDs, they are very delicate. So we have to always handle with carefully. We have to handle it very carefully. Yeah, and also components have sharp edges in them. So be careful while using. Okay, let's start with this session. This is these are the things which will be included in this session. So first we'll start off with microcontrollers. What are microcontrollers and where is it used, etc. Then the famous Arduino. Everyone knows what is Arduino, right? Or fret not. We'll explain what is an Arduino, where it is used, what are the applications, why it is used, why is it so famous, etc. Then Arduino runs with some software called Arduino IDE, which will be explaining what is it and how to install. After that, the kit which is suggested will explain all the components in the kit. We'll show you photos and we'll explain you what each component does. Please do not annotate, please. All right. Then we'll go to something called Tinkercad, which you'll get to know and use code blocks and code. And finally, we'll end the session with projects. We are going to do 4 projects today. One is blinking LED, then using push button, then a buzzer, and finally buzzer with LDR, which will tell you what is that. Okay, over to Sanjeev.
Yeah. Yeah. Hello, everyone. I'm Sanjeev B, and I'm also a coordinator at Electronics Club C5 IIT Madras. So hope you all are doing well in these testing times. Now let us just get on with the session. So let us start with the formal welcome to the world of electronics, as Arduino will be our gateway to anything that you might be wishing to do in the future, because this contains the basics. Yeah. So basically, at least I hope in the past few days you might have heard of the word Arduino throwing around, like as in we suggested you to buy the Arduino kit, etc. So people keep talking about what Arduino is, but nobody really says what it is, or you probably wouldn't have heard what it is. Arduino is Arduino is an example, or one of the most popular examples of something called a microcontroller. So when you go to Wikipedia and type that microcontroller, this is the definition that you come up with. It has a lot of technical terms that we do not need right now. So in layman's terms, what is a microcontroller? It is basically the brain of a circuit, right? So in any circuit or any project that we're attempting to create right now, we will have input devices, output devices, actuators, etc. Right? So in order to, and there should be a brain or a controller for which you or a device through which you can control all of these, right? So that is called the microcontroller. So the microcontroller can be programmed to work in a certain way by the user using the IDE, or like for example, the different microcontrollers come with their own different IDEs. You can use different programming languages, etc., to code the microcontroller. But for this session, we're going to be focusing on the Arduino and the Arduino IDE, which is based on C++, and it is pretty well developed. But yeah, fret not, we will not be assuming that you guys have any prior coding experience, as we will be using something called code blocks that I will be explaining to you in a bit. So you might have heard the terms. You might have heard the terms microcontroller and microprocessor being thrown around a lot, and sometimes they are used interchangeably also, but they shouldn't. There is actually there's actually a stark difference between them. So a microcontroller is basically is essentially, as the name implies, I mean, a microprocessor essentially, as the name implies, is just, it contains only a CPU, and it is used for computing data. So basically, it doesn't have any input output memory, or all of these should be given as external modules. Whereas in a microcontroller, it contains the CPU, memory, and the input output ports. Microprocessors tend to be complex and expensive because the computations performed by microprocessors are generally much more hardcore, or much more carry a lot more computation to do than a microcontroller, which is why the microcontrollers are can be found at nominal prices as well. Yeah, so moving on. Yeah, I understand that we're starting off with a bit of theory. It might get it might look a little uninteresting right now, but trust me, it'll get better once we get into the demo session. So just hang on and just understand these, because in order for the projects that we're going to be doing today, these are the prerequisites. Like a decent understanding of these would help you appreciate the projects even better, rather than just us giving you the circuit and telling that, yeah, this is what it does. So you've heard me talking about controlling sensors using microcontrollers, etc., but we never really told you how we're going to control them. So basically, any device is going to be controlled by a bunch of signals that were given to them. So the signals are basically electromagnetic pulses or electrical current that carries data from one system or network to another. So there are two main types of signals, as you can see from the slide: analog and digital. So the analog signal is a time varying and generally bound to a range, but there are infinite number of values within the range which this analog signal could take. Essentially, it is continuous. It can be used to represent it can be used to represent things like temperature, the FM radio signals, or the photocells, light sensor, etc. Because over here, because when you compare it with the digital signals, which just have two states, 0 or 1, or off or on. So these are the signals that can be easily understood by the computer, because the primitive way of controlling the computer is using zeros and ones, or giving them power and turning them on and off. So these are the digital signals. These are what the digital signals are. But as you know, a lot of real life instances, digital signal in real life, most of the things exist in an analog format, as in they can take a value, they can take any value and not just assume two values. Yeah. So now that we're done with this, if you guys have any doubts, you can put them in the chat, or else we could give it to Anish, who would continue with the next slide.
All right. So what is an Arduino? Okay. So Arduino is it's a platform. It's a company. It's created this platform. It's an open source platform. What does that mean? Open source platform means that anyone in this world can view your code, and I mean, you can share your code. Others can modify your code. As they see, they can modify the code. As in, we can share our codes, and everyone can see the source code, etc. That is open source. So it's a platform which has two parts. One is the board, the microcontroller board, which you see on the right. That's the board. And another part, software part, is IDE, which runs on your computer, where you can write the code and upload it. And you can program the Arduino microcontroller. Okay, so why do we use Arduino? Why is it so famous? Because it is easy to use. It is very easy to use. As you see the meme, when did you become an expert in Arduino? Last night. Means it is that easy. Like if you put some time and learn, you can do it easily. Like, yeah, and it is very interesting. It is easy to use. It is flexible. It is one of the best options for beginners. and it is inexpensive also, and it is small so that it's portable, and power consumption is also low. Okay, so okay, what can we do with that? Wait. Yeah, so with Arduino we can connect to a variety of switches and sensors. We can control things like light, we can control motors, and yeah, there are many applications of Arduino. We'll explore that later. Okay, schematics of Arduino. People who have board can put the board beside them and watch. So there are, okay, so there are, so there are 5-volt power pin, 3-volt power pin on the left side. You can see that there are 3.3-volt power pin and 5-volt power pin on the left side. These are the power pins, and then there are two ground pins. Two ground pins on left side and one ground pin on right side. Both are equivalent, but the ground pins are on both the sides. Yeah, but both are equivalent. Then there are something called analog pins, which are used for analog reading and analog writing uh, devices which use an analog readings and all. Then on the right side, we can see digital pins. Yeah, as we just seen the difference between analog and digital. Yeah, those are the digital pins. Okay, yeah, and you can see this 80 mega 328 microcontroller at the center. This, yeah, that is all right. Yeah, so it has 14 digital pins, 6 analog input pins. Yeah, and this is USB plugin at the on the top side, USB plugin, which will connect this to our laptop or PC using a USB cable. And there is an external power supply. We can connect it to battery too. Also, you can see there's a tilde sign with beside a few digital pins. Yep. 3, 5, 6, 9, 10, 11. Those indicate that they are PWM. They have PWM. Will not go into detail of what is it, but yeah, yes, tilde PWM. And there is something called reset button, uh, which I'll be showing you or directly in our first project. Yeah, and beside you can see the specifications. Input voltage 6 to 20, recommended 7 to 12, flash 32 KB flash memory, 2 KB SRAM, 1 KB. You can read, you can search in Google what they mean, but we don't need to dive into them right now. Yeah, next slide, Sanjay. All right, these are applications of Arduino. You can see there are many interesting projects which we can do with Arduino. Home automations like gas sensors, lighting up LEDs, yeah, etc. Control, making an automatic door machine. Yeah, you can do many projects like parking lot counters, weighing machine. Yeah, and we can use ISP programming. We can do remote controllers also. We can do traffic lights. We can do robotic projects, etc. And many more. Okay. Uh, so before we go to other parts, we'll show you the installation of Arduino IDE. Sanjay will take over from here.
Yeah. Yeah, thank you for that, Anish. So now that we know what an Arduino is, how it looks basically, what are the ports that we have, and we need to look at how we can program the Arduino, right? So people who have the physical code can follow, who have the physical components can follow along and install the Arduino, and people who don't and who are planning to buy the Arduino, because if you have a physical Arduino board, you cannot use the simulation software. You need to use this Arduino IDE to to do circuits in real life. So if you're interested, people who are going to buy the board or people with the board can follow along the next few minutes that I'm going to show you how we're going to install the Arduino software. So the Arduino software is free to install, considering the fact that it is open source, and it is a pretty nice software. And this is the link that we're going to be using to download Arduino. I will just be pasting this link in the chat. Just a second. And yes. So, there you go. You guys can click this link and you guys can come to the page that I am on right now. And now, as you can see, you have a few download options. This is the latest version of the Arduino IDE 1.8.15. As you can see, there are a few download options. There is a Windows app, but we think that we found out that a few of the files over there are kind of glitchy. So we will stick with the first installer, that is Windows 7 for newer. So if you guys have gone to the, if you guys have come to the website, you guys can just go click on it. And it would they would ask you if you want to support Arduino IDE. So just click just download and select the. As you can see, I've already downloaded the installer, but I'm just going to do it again. And you can just select where you want to save it, because this is where you're going to access it to install. And so I'll just click save. Yeah, and so the Arduino installer, it might take a couple of minutes depending upon your bandwidth and your internet speed. So for me, it's already downloaded. So I will just go ahead and I'll go to the file where I'll go to the drive where I saved the Arduino installer, and I'll start installing it. So I've saved it over here. So I'll just go ahead and double click this and it'll start running. Yes. And if you guys can see, just first they will give you a setup license agreement. Click I agree. And then over here, it is essential for you to click on all of these options. Select all of these options, because we need all of these files. And then click next. And you can just this is the destination folder. It would by default it would probably put it in your C drive if you're using a Windows machine. And if you want to change the position where you are going to store the Arduino documents, you can go ahead and browse and change it. But I would suggest you just leave it on here for now. And you go ahead and click install. The installation will take probably a couple of minutes, depending on how fast your computer is. And let's just wait for the system to finish installing. Within that time, I will show you the few slides that we've created, just outlining the process that we just did now. So while my software is installing, I'll just show you. So first, we go to this website that I've pasted on the chat, and over here you go ahead and click. You go ahead and click the Windows 7 or newer editions, and you click that, and then it will download. You just select the place where you want to download the installer, and it will install. And the next you just go ahead to the same directory where you saved your installer. Open the installer. Agree to the terms. And then over here, the important part is you need to choose install all the components. So you need to choose, if suppose some of the checkboxes are not checked, just go ahead and click on them, because we need all of them. And then hit on next. And over here, you can choose the directory where you want to install it, but we recommend going ahead with the default directory that the installer suggests. And after that, just go ahead and press install, and it would probably and it will start installing. So I'll just give you a couple of minutes to finish installing, and people who are installing, just type an yes in the chat and let me know when you're done with the installation, and we can proceed further. Yeah, I'll just wait for like a couple of more minutes, and in this time you could ask us the doubts if you have any doubts based on yeah, I mean, if you don't have components, you could always install it now, and you can if you and buy the components later, because this might be useful. But if you're not planning on buying the components, then I would suggest not. I would suggest you can just stick to the simulator that we're going to use. I'll just wait for a minute more, and then let's continue with the next step.
Sanjeev,
Yes.
like there are few doubts. Can you check them out?
Okay. So what are the doubts? Okay.
In the chat, small doubts.
Okay. I'll just look at it. Is switch analog or digital? Which switch are you talking about? I assume. I mean, a general switch is analog, is digital, right? You could either have the on state or the off state. So a general switch will be digital. It's off and on. Okay, yeah. Okay, Adil has already answered that. Okay. Muhammad Riaz, can you please rephrase your question? I don't understand what you mean by what is representing UNO. Yeah, I believe you. Okay, yeah, go ahead. Yeah, you can take up.
Yeah, we can use Arduino Nano.
Yeah, but note that some of the ports and the specifications might be different. So just keep that in mind while you're doing the project. Okay, yeah. So now, okay, cool. Okay, so now let's just continue. So once you have installed, go ahead and connect your Arduino board with the printer cable that you would have received with it. Just go ahead, continue using this pin, connect the USB to your computer, and connect your printer cable to the port, the USB port that we showed on the previous slide. This one precisely, the USB plug. And once you do that, you must once connected, the green power LED, the green LED named power, should be turned on, should be turning on in your Arduino Uno. And yeah, if you had used the installer that I had done, all of your drivers should have automatically been installed. Okay, so now let's just move on to the next step. So the next step is you will want to check. After connecting, you will want to check whether your Arduino Uno is connected and working or not. Let me just show you. Yeah, so I'll go ahead and I'll just close my Arduino setup has completed, so I'll close it, and then I'll just go ahead, search, and I'll just search for Arduino, and I'll open the app. Okay, so as you can see, the few things that you have to check when you first open your Arduino is you have to go to tools, and you have to check if your board is Arduino Uno is selected, or else just look at the drop down menu and select your Arduino Uno. Once you make sure that is the tool that you're going to be using, if you have the board at home, when you connect, when you connect it to your when you've connected after selecting the correct board, when you connect it to your PC, and when you go to tools and go to port, you should be able to see the Arduino Uno in say a number that is representing your USB port, and on the brackets it should say Arduino Uno. That is how you know that the IDE recognizes that you have connected a board to your computer. This is very important. So people using Arduino Nano, I think you should select Arduino Nano from the drop-down list for this one. Just a second. You could go to tools, and people using Arduino Nano could just go to the board part, and you could select Arduino Nano, and this part would change. The Arduino Nano would change, and again when you go to the again when you go to your port part, you should be able to see a board. You should be able to see that a board has been connected, and in a COM port with in the brackets you should give the no, like it should represent what board you've connected. It should say that you've connected an Arduino Uno. Once all of this is done, like I'll just switch it back to Arduino Uno. All right. So once we're done with this, let us just let us go ahead and execute and upload an example code. So basically, what we're going to be doing is after checking all of this, you need to go ahead and check if your Arduino is working. So your Arduino Uno comes in with a built-in LED that, connected to pin 13, the digital pin 13. That will glow when this that will blink when this code is executed. Okay, wait, I'll just show you. So if you want to find this code, there's already an inbuilt code. We'll teach you how to do this later, but for now, just check if your Arduino Uno is working. So go to examples, and then you could just go to basics, and you would find the blink, and that would open this dialog box with the code already existing. And if you've connected your Arduino Uno, you should just go ahead and click this to upload your code onto the Arduino Uno onto your microcontroller, and it will take some time to upload. And once it is done, you should be able to see the inbuilt LED blinking with a period of 1 second. Right now, I'll give it to Anish to show us a demonstration of how the LED blinks. I'll stop sharing now.
Yeah, 1 sec. I'll set my camera.
And also answer, like, just adding on to what the people had answered for the question from Sahil. If you want, if you're going to make a bulk component, with a microcontroller in it, you would not use the general. A company would not use a general microcontroller available on the market like an Arduino or an ESP32. They would use custom microcontrollers with custom processors that will suit their use case the best, and they will use that to because they will use that to reduce the costs, because then they can eliminate all the unwanted components that are presented in microcontrollers, because enthusiasts might need different aspects of the code for the different types of programs. Okay, wait, Anish, you're gonna do the breadboard now. So do I explain the breadboard, or you're gonna do the internal LED? Bro, you're gonna do the internal LED now, right?
Oh, sorry, I was unmuted. Sorry. One sec, I'll be doing. Okay, so this is an ESP32 board actually. This is not an Arduino which you all have. I'm having a ESP32 board. This is also a microcontroller, uh, but it is a little advanced than Arduino. Arduino is for beginners. This is a little advanced. Uh, we'll be covering up the differences in the later sessions we'll be having. Okay, and it has an internal LED, as you can see this. This is an internal LED. And I'll connect internal LED and I'll run the code. Let's see what happens. Okay, this is called a jumper wire. I'll explain you in the component section. So I've connected my internal LED pin to pin number 12, which is a digital pin, to pin number 12. And I'll be uploading the code now. All right. Yeah, first I have to connect the USB cable. This is the USB cable, and I'll be connecting it to my laptop. See, this is not internal LED. This is just indicating that Arduino is powered on. It is connected to PC and it's powered on. Okay, and now I'll be uploading the code. 1 second. Takes time. Yeah, I've uploaded to this is blinking LED. See, it's blinking.
Yeah, so as you can see, Anish essentially did what we have done using the Arduino code, but for a ESP32. It is also a basic microcontroller, but the ports would be different. But right now we're not concerned with the code. Right now we're just checking if our Arduino is working. So when you upload the already example code that I presented to you, like it is already existing in the IDE. When you go to File, when you go to Examples, when you go to Basics, and when you select the Blink, you will get the program. And once you upload it into your Arduino, even you should get an
All right. So how to stop this? Um, I can stop this by removing the pin. Okay. Yeah. It stopped. And when I connect it again, yeah, it stopped blinking. So I said there is a reset button on the microcontroller, right? So even this microcontroller is having a reset button. So what happens if I click reset button? See, it's automatically blinking. I didn't upload the code this time, but it's blinking automatically. So what happens is the microcontroller stores the what we did last time, and when we click on reset button, the code is automatically the code is used automatically, and yeah, it starts blinking. It has a memory, so which it is stored in memory, which can be used when we use the reset button. All right. Yeah. Let's continue. No, Sanjeev, you aren't audible. I'll tell you what a jumper wire is. What there are three types of jumper wires. I'll tell you in the first project. When we do the first project, I'll tell you what they are.
Wait, am I audible now?
Yes, Sanjay, you are audible right now.
Okay, I'm very sorry for that
Continue.
inconvenience. There was some problem with my mic, so I had to switch headphones. Okay, yeah. So now so now we basically seen how the Arduino. What Anish just showed you was his code, and what I just showed you the code that you need to upload on the Arduino Uno to get the same output. Now I will be presenting my screen again, and let us continue with the session. Now that we have installed the Arduino IDE. Okay, 1 second.
All right. Also, I missed one point. So people using Arduino, you need not use any jumper wire for lighting up the built-in LED. You can directly just connect the Arduino to your PC and just upload the code. You don't need to connect anything. Mine is a different one, so yeah, we need to use jumper wire. Yeah. For Arduino, you need not use any jumper wire.
Yeah, you just need to connect it to the PC and run the example code under file, examples, basic and blink, and you just need to upload that to your Arduino Uno, and until you supply the power, it will keep blinking with the inbuilt LED. Okay, yeah, now I'll just present my screen. Okay, yeah. Now that we've done with the basic installation, let us continue. Anish will explain the components of the kit that you have bought.
Yeah. So people who have received the kits, who have the kits, can open the kits and see the components as we go through it. Yeah, the first one is, you all know, it's a LED. LED stands for light emitting diode, if you don't know. So yeah, it's a light bulb. It lights up when electricity is passed through it. And then on the right side, it's an RGB LED. It has 4 pins. One connects to red. One is red pin. One is blue pin. One is green pin, and one is cathode pin. Yeah. So depending upon on which pin we have connected and on which pin we have activated or passed current through which pin, the LED lights up. So if we can connect green pin and we pass electricity to green pin, then it LED glows green. And if we connect blue pin, it glows blue. And if you connect green and blue, it comes in a combination of green and blue. I don't know what's that green and blue combination is. Okay, cyan, I guess. Okay. Okay, this is a 7-segment LED. You have seen a calculator, right? You can see the number. It has two boxes kind of thing. It's like a 8. And depending upon which lines are lighted, you get a number. Yeah. Yeah, that is 7-segment LED used for showing a number. Okay, and this is a buzzer. The next component is a buzzer. Yeah, it makes noise on different frequencies. We have to connect it to power supply and give it a specific frequency, and it starts making noise at that frequency. Next slide. All right. A capacitor. I don't know if you're familiar with capacitor. It basically stores and releases electrical energy in the circuit. When we pass current through it, it stores energy. It has two phases, discharging and charging mode. When we pass current, it charges up, and yeah, it charges up and stores energy, and otherwise it discharges. Yeah, that is capacitor. And a resistor, you all know a resistor. It is restricting the flow of current in a circuit. Yeah, okay, this is a resistor, and the resistors look like this, and it has different colors on it. The color coding, depending upon the color, they define the resistor value. Like one color coding may have 220 ohm as its value, one may have 1000 ohm, one may have 2k ohm, etc. Okay, the next component is self-locking button. This is like a press button only. When we press it, it gets locked. Yeah, and it remains in the press state only. And but once we press it again, it springs back and it becomes normal. Yeah, that is yeah, like switch buttons on washing machine or something like that, or some electronic appliance. Okay, this is a push button. When you press it, it will be pressed, and once you release it, it springs back automatically, like a doorbell. You press it, the bell rings. Once you remove your hand from the switch, it goes back to the normal position. Yeah. Next slide. Please. Okay, this is a photoresistor. The top one is a photoresistor. Uh, what it does is it measures the room, if the room is light or dark. It the yeah, it is made up of semiconductor materials, and yeah, it detects how much light is falling on it, whether it's dark or light, or how much light is there, etc. That is a photoresistor. And next is ultrasonic distance sensor. Okay, it looks like a speaker actually, like a boom box, but it is not. It measures the distance. It uses ultrasonic sound wave. It sends ultrasonic sound wave, and the it's the ultrasonic sound wave hits the object, and the sound wave returns back to the sensor. Based on the time it takes, it determines how far is the object. Yeah, distance sensor, as the name suggests, it tells the distance from the sensor to the object. Okay. Next is a humidity sensor. As the name says, again, it determines how much humidity is in the environment. And yeah, we can connect it with all these components. We can connect it with Arduino, and we can extract the values from them and print it or see it anywhere we want. I mean, we can use those values. We can get those values from them using Arduino. Next is a temperature sensor. Again, as the name says, it measures the temperature of the room. Yeah. Next slide. All right. This is PIR sensor, passive infrared motion sensor. So what it does is it sends infrared motion, infrared. So if an object moves in front of the sensor, it detects the motion and says, "Yo, someone is moving there. Someone is moving over there." Tells us that. That is a PIS sensor. And a touch sensor, yeah, you can, if you touch it with the, yeah, when we touch it, the circuit gets closed, and with the help of, with the help of that, we can control different circuits. Touch sensor. And the next is the interesting one, LCD screen. It's a 16 by 2 LCD screen, as in it has 2 rows and 16 columns. It can type 32 characters. We can it can show 32 characters at once. Yeah, and yeah, you may have used this. You may have seen this LCD screen at many places like swiping machine or bus conductor, using that that device for printing tickets and all. On that also LCD screen is there. Even some phones use LCD screen, etc. Okay, the next one is magnetic reed switch. It is used for controlling the flow of electricity in a fan. It based on magnetic field, uses magnetic field, and helps. It controls the flow of electricity in a circuit. Yeah. Okay. On the left side, it's IR communication and transmitter signal. What transmitter, IR transmitter, what it does is it sends out a IR wave. It sends out the IR wave, and the IR wave hits an object, and when it comes back, it is received by the IR receiver. The IR signals are IR receivers are used to check the IR signal, to receive the IR signal. And then this is the IR remote. With when you press a button, an IR wave is generated, and with the help of IR receivers, we can receive those waves and use that to control circuits. Yeah, we have to program. We have to connect them to Arduino, and we have to program, and we can connect circuits. All right. So I hope you all installed Arduino IDE now. Yeah. Okay. So what is Arduino IDE? As I said, it's a software part of Arduino, where we can type a code and upload it so that to the microcontroller, and it runs. So it is an open source software, as I said, and yeah, it is very friendly, user friendly software, and yeah, it is very good for beginners, and it is available in multiple operating systems like Mac, Windows, Linux, and yeah, it has many inbuilt functions and commands which makes our lives easier when coding. Yeah, and it supports C and C++ language. Arduino actually uses programming language of its own. But it is derived from C and C++ languages, but yeah, it is derived from C++ and C languages, but it does some more inbuilt functions in it, which is with which we can run an Arduino. And yeah, it is very user friendly. We can learn it very easily. We can understand the code and easily. Yeah, and the IDE is also very user friendly to use. All right. Okay, over to Sanjeev. Sanjeev.
Yeah, thank you for that, Anish. So, okay, so most of you guys, we've introduced you to the Arduino IDE, how this program is run, and we just showed you the blink LED. And if you if the participants, if you guys are familiar with the C++ or the C programming language, then you might be able to get like a basic understanding of what each function does, because it's because C++ is kind of high level language. So but if you don't understand what the code is, don't worry. Now I will be introducing you to and Tinkercad. So now that we're done with all the theoretical parts and the installation of the Arduino IDE, now we can move on with the demo that even people without the kit can follow by just simply going on, because the Arduino IDE, as we've shown, is where we're gonna where we should actually be coding to for the working of our projects. But since we don't have the kit, there's a online simulation tool called there's a simulation tool called Tinkercad, which is a pretty well developed tool that has almost all the features that we need to that we need for today. So just go ahead and I'm sorry, I'm getting some disturbance. Okay.
Hello.
Yes. Wait, I'll just mute Aishwarya. Yeah. Okay. Cool. Okay. So please, everyone, keep your mics muted. And
Hello.
yeah. Yes.
Sir, is there any driver for Ubuntu?
So for the different, so we've showed you the installer for Windows. So you could just go ahead, and if you want, I can give you the link. There is a guide to which you can use to download Arduino on your Linux system. Just a second, if you can follow that, and wait, I'll just send it to you right now. Yep, just a second, I'll just put it in the chat. Yeah, so you can look up this web page, and they will guide you as to how you can download the Arduino. It has a step-by-step explanation as to how you can download
Sir,
it for
is
different
there any
platforms.
driver for Ubuntu? The connection is not showing.
Wait, what board are you using?
Arduino Nano.
Okay, so then has your platform have you installed Arduino?
Yes.
But the drivers are not working, huh?
Sir, sound.
Okay, yeah, I'm sorry. I think few of the cards in our chat can help you out, because right now we're holding up everybody else who has an Arduino.
I'll share the link. I'm checking for them. I'll share the link or the guide in the chat box. Sanjeev, you can continue.
Yeah. Okay. Thank you. Yeah, let's just not hold everybody else with the Arduino Uno. So now I'll just start presenting again. One second. Okay. That. So hopefully you can see my screen now, and we've dropped the link to the Arduino to the Tinkercad circuits in the chat box. So over here, you guys, since you don't have microcontrollers or other electronics, we're going to use this Tinkercad website. So basically, for people who are new to the platform, when you're gonna go for Tinkercad, it'll probably look something like this. I'll just open an incognito tab and paste. Yeah, you'll probably go to the landing page of the Tinkercad website for a new user. So over here, you could just go ahead and click on, if you don't have an account yet, click on join Tinkercad, and you click on create a personal account, and then you can sign in with your Google account. It will barely take a couple of minutes. And once you do that, I'll just close this window. I'll go back to my Tinkercad. So I have already downloaded I've already registered on Tinkercad. So yeah, so basically you would go to a dashboard somewhat similar to this, and we're not going to be working with 3D designs today. We're going to be working with circuits. That is the ID. This is the one where we can use the Arduino, create Arduino circuits. So go ahead and click on create new circuit. I'll just wait for like a minute for you guys to follow along. If you if you guys are new to the Tinkercad website, like for you to register and come to this basic page, come to the basic workspace that we have here. Yeah, so Tinkercad is basically it's a pretty interactive, it's a pretty user friendly and beginner friendly, has a pretty beginner friendly interface. So new users can find it very easy. It has a really nice graphical user interface where you can select all the components. We'll go through them. We'll go through the features one by one. So I'll just wait for like 30-40 more seconds, and then we'll continue with the session. Until then, if you have any doubts corresponding relating to what we thought in this up till now, you guys could put it in the chat. Okay, yeah. I hope all of you would have registered on Tinkercad and would have created a new circuit, gone to circuits and created a new circuit, and you're probably looking at a page somewhat pretty similar to this one. So as you can see, you can over here, this is the components pane where you have to select the components from. So I'll just you can just scroll down here and look at all the components. So this is basically the filter for the components that you want to see. So just go ahead and click that. You can see you have the different views for the amount of for the components that you want to select. You can either have the basic components. So Tinkercad classifies these components as basic components. And if you want to look at all of them, you can just take a look at all of them. Like you would have a lot of components that might not be needed for beginners. So I'll just go back to the basic. And if you also if you want a particular component, you could use the search bar over here to select the component. And yeah, so we'll just go, and there are a few starter kits which are basically pre-made circuits that beginners will find useful. For example, the Arduino, you can find some pre-made projects, but we will be starting with the basics. Yeah, and also there's a different view. So this option over here, if you click that, so this is the pane view of the components list, and if you click that, you will find a brief. This is the description view, so you can find a brief description of each component in case you're unaware of it. In case if your component seems new to you, you can just look at the brief description, and you can see what it says to get a basic idea of what the component does. And yeah, so far we've introduced you the Arduino microcontroller, which we've stated that it is the basic component for any project. So let me just go ahead and bring that out. So go ahead and type in Arduino, and the first option would be at the Arduino Uno R3. So I'll just go ahead and drag it out. So as you can see, this looks pretty similar to the Arduino Uno IRL. So you can see the digital pins that we introduced you to, the analog pins. This is where the processor is. This is with the USB cable, etc. The ground pin, the 5 volt, the 3.3 volt, etc. So basically, so now we'll show you. So basically, to select a component from this window, you just have to click on it, and it'll automatically come here. And to drop it again, you just have to click on any place, any position on this workspace. And if you want to change the orientation or how you view this, so you can just use the scroll wheel on your mouse to zoom in or zoom out at any particular position. For example, I want to zoom in here, zoom out. You can use the scroll wheel. And you can also, if you want to move around in this workspace, just go ahead and click anywhere in the workspace apart from the component. And using that as the using that as the relative position, you can move around anywhere. Say here, I want to go here. I just want to do this. So this interface is pretty smooth and pretty useful when you're having multiple components and you just want to zoom in and look at each and every one of them. And so go ahead and select on the component, and as you can see, you get a components information pane. Over here, you can change the name of the component. Over here, it is called the Arduino Uno. I'm just going to rename it to the Uno. The name was just one. I'm just going to rename it to Uno. So that way you can name each and every component. And now over here, as you can see, you have a few tools up here that you can use for this that you can use while creating your circuits. So let's just go ahead and I'll explain each and every one of them. So this one is a rotate. It rotates clockwise by a very small angle. So you can just keep rotating it. So this is very useful in cases where you want to change the orientation of the components with respect to each other, because you will have a lot of components cramped up together in complex circuits. So when you want to make the wiring look more pleasing to the eye, and or to make the circuit more readable, you can change the orientation of each and every component that this Tinkercad has to offer. I'll just go back to the default setup. And as you can see, this is the delete button. So any component I click on, and I click on delete button, or you can use the delete key in your keyboard as well. So I click on the delete trash can symbol. It'll give me a warning sign that I'm going to delete a component. And if you click OK, this will disappear. But right now I don't want to. I just want to keep it there. So I'll just hit cancel. And now let's go ahead and I'll show you this is basically, if you've been using Word, Microsoft Word, or any other app for that matter, these are just the easy ones. So basically, this is the undo pin. So if you make a mistake, you could always go back. And if you go back, if you click far too many times, you could always click on redo and come back to the exact time in which you had the desired circuit. And the next two options are for annotating. So basically, annotations are used because you and I might create a circuit, and we might share it to somebody else. But for them to understand what the circuit is, because it is simply hard for everybody to read the circuit using just the wiring. So you could use annotations. So you could just write your note here. I'm just going to go ahead and annotate on this, saying that this is Arduino Uno, and so that's an annotation over there. And I can create as many other annotations I want for different components. And sometimes you might also start annotating too many things, and it might get in the way of you actually understanding the circuit. See, there's a view. So if you click this, you could hide all the annotations, and you can just open this again to look at all the annotations that you've done. And these two panes I'll explain when we're actually making our first circuit. Okay. So next I will be introducing you to the LED project using an external LED, not the internal LED. So basically, for connections, the connections for the LED project, I'm just going to bring out a normal LED. I advise you not to emulate this on your kit right just yet, because I'm going to show you a beginner mistake that you might make and destroy your components. So you may think, okay, I've got an LED, so I'll just connect them to the input and output, and then I'll just work with them. So over here, as if you just zoom in, you will have two pins, the anode and the cathode. So I'll just go ahead and connect the cathode to the ground pin, because that is where the cathode should be connected to. The ground pin is usually in black in color. As I stated, these two windows can be used for changing the color of the wire, and this can be used for changing the type of the wire. So I'll just make it in black. And then this other pin, let me just go ahead and connect it to, say, any digital output pin. And I'll just go ahead and change the color, change this color to red, because it is usually a live wire. And now this is this is a basic circuit which is done. And now we want to code our circuit, right? So for that we don't like on the Arduino, you would actually have to type down your code and the functions and the programs. But Tinkercad gives you a pretty nice feature called coding using code blocks. So these are basically for beginners, and so I'll show you how you can use them in just a minute. So go ahead and whatever the existing code you have, just go ahead and drop it in the trash can or right over here. And so you can, so these are basically bubbles that you can select to, instead of having to type in all the code. So there are already the basic functions. So there's output, you can set a pin to high or low, etc. So, and you can input, you can read the value from a sensor. You can just note, this is just commenting in the program, just like you annotate in a circuit. If you want to make your program more readable, you use the comment block, and then you have the control things where you have conditional statements and loops, etc. And the math, where you can do basic arithmetic operations and expressions. And here you can create new variables. But for this one, I'm just going to basically show you how how we would try to make an LED light up. So I'll just go ahead and grab this output pin called set pin 0 to high. So over here, you can, in the toggle menu, you can change the pin that you want to use. So since over here the anode of the pin is connected to the D10, that is the 10th pin, that is the 10th digital pin. I'll go ahead and set the digital pin 10 to high. Again, I repeat, do not try this on your offline kit just yet. I'll explain to you what is wrong with this circuit when I start the simulation. So this is it basically. So when you need to light up an LED, this is it. So you just need to select this bubble, bring it over here, set the pin that you've connected the anode to as high. That's all. So I'll just start the simulation now. As you can see, the LED is lighting up, but you guys can, as you can see, the LED is lighting up, but there is an exclamation mark which says the current through the LED is basically higher than the recommended value or the maximum value that this component can use. So for that, that is why I told you not to try this out offline just yet. So to prevent this, so in any circuit, to reduce the amount of current flowing, we use the resistor. So I'll just close the code window over here, and I'll go ahead and over here, there's already a bit, like in the basic pin, the first component is a resistor. I'll just go ahead and bring it over here, and let's just connect the resistor between the ground. Wait, let me just delete this wire. So I'll just click on this wire, and I'll click the trash can, and now I'll just connect this resistor to the ground, and I'll make it black, and then I'll connect this to the cathode. So, and now in the resistor, you can, over here is the resistor pin, you can change the name of the resistor, and to change the values, you can access the units that you're using, say now kilo ohms, but generally the default is we would be using a 220 ohms resistor. As you can see over here, the color coding changes as and when you change the value of the resistor according to the universal standard. Say I'm going to change this to 400. As you can see, it automatically changes the color. In the kit that you might have received, you would have gotten these color coded resistors, and there is a color coding chart that you can look into and calculate the amount of resistance that each of it has. Or else you could just, if you're too lazy to do so, you could just come to the Tinkercad website and type in the amount of resistance you want in order for you to choose the resistance from the kit you have. So I'll just go back and type 220, and this is the color coding that represents the resistance of 220 ohms. And now when I run the circuit, the error code should be gone, and the code is still the same. I'm just setting this. As you can see, the exclamation mark is gone, and the code is complete over here. And now I will just introduce to you what a breadboard is. So over here, we just connected the pins and the components directly to the Arduino. Okay, wait, actually, are you guys following me up till now and have any doubts? Okay. If you guys have any doubts, you can ask me. You can put them in the chat, or else I'll just move on and I'll explain to you what a breadboard is, and then after that I'll answer your doubts. So basically, now as we've seen, this is the basic setup for the code. And if you want to have the blinking LED, we will do it using the breadboard. So now, as you've seen, we've used only 2 components. And if you over here, so we've just directly connected them to the Arduino Uno. But when the number of components increases, as it will in the future, when you use more sensors, actuators, when you use more components, so it'll all get very messy, because there's only a few ground pins and 5-volt pins, but we need to connect almost all components to the ground. So for that, we use something called the breadboard. So let me just go ahead and discard this project. I mean, discard all of the components. Delete. Yes, I'll delete it. And I'll just go ahead and delete this. I'll go ahead and delete this. Okay. So for complex circuits, we use something called a breadboard. A breadboard is a simple. Okay, I'll just show you the slide now for the breadboard, and then like I'll show you how we access it on Tinkercad. So I'll present it. Yep. Okay. So now basically, spotlight, disappearing pen. So over here, a breadboard is basically is a simple device that lets you create circuits without the need for soldering. So soldering is when you make circuits for actual products, you would have to join 2 metal wires together, right? So the process is called soldering. You would just heat them up until they melt, and you would connect them together. But as enthusiasts, we just want to keep trying new circuits, right? With the one microcontroller board. So we can't be soldering each and every time we want to try out a project. So for that, we use something called the breadboard. So over here, the breadboard, as you can see, is split into the power rails at the top and the bottom, and the terminal strips in the middle. So the power rails are where you would usually connect your 5-volt and the ground pin. So you'd connect the 5-volt pin to say this hole, and you would connect the ground pin to here, and you would connect the 5-volt pin from here to here. So basically what the power rails do is the horizontal lines in each power rail are all connected to each other. So for example, in this power rail, all of these lines in the red row are connected to each other, and no 2 rows will have the same connection. So the same thing goes for the negative bus as well. So the one marked plus is called the positive bus. The one marked minus is called the negative bus, and you usually connect the 5-volt to the positive bus and the ground to the negative bus. And as you can see in the middle, you have a bunch of other strips called terminal strips. So these are connected column wise. So basically all of these 5 holes in the column are connected to each other, and no two columns are connected unless you put a wire between them. So these basically act as a wire, are equipotential points, and these help us in making the circuits much easier and simpler. And yeah, so now that we understand what the basic layout of the breadboard is, the schematic is, I will go ahead and show you how we can get the breadboard on the. I'll go ahead and show you the breadboard once again. Yes, Mohammed, I will be showing the same circuit using the breadboard also, so you need not worry. So then yeah, so where was I? Okay, yeah, I was about to show you the breadboard. Okay, so over here, just go ahead and type the breadboard. Go ahead and select this breadboard small and bring it to your workspace, and you can zoom in and see as it looks almost similar to. It looks very similar to the photo that we've showed, the schematic that we showed you on the slide. And there's a cool feature in Arduino whenever you put your cursor on the hole on a connection hole, it'll light up all the other equipotential points or the points connected to it directly using using green circles around it. So so over here, as you can see, the power rails are horizontally connected, and the other ones are connected. The column ones are connected column wise. And so now basically I would just introduce an Arduino, and I'll show you what the basic connections are before we start off with any other project. So I'll get our Arduino microcontroller over here again. And so So the basic practice is to connect your 5-volt pin. That is, I will just replace it here, and you will be connecting your 5-volt pin to your positive bus. And yeah, and another cool feature in Arduino is that you can reshape your wires using these points where you click. So for example, I'm dragging a wire from here, and I click there once, it'll create a joint over there. And if I finish the connection, now I can use those joints to change the alignment of the wires and to change how they look essentially. And if I want to introduce a new joint, I'll just go ahead and double click anywhere on the component after it is selected, and it will introduce a new joint. So now let me just go ahead and delete this. I'll just go ahead and delete this component. And yeah, so so back to the connections of the breadboard. As I've told you before, the 5-volt of the live wire is usually in red in color, so I'll just change it to red color. And the ground is connected to the negative bus. Yeah, so now the ground is connected to negative bus, and I'll change it to black color. And it is usually good practice to connect both the power rails. So what we will be doing is connecting the negative bus to the negative bus on the top. I'll just align it, and connecting the positive bus to the positive bus on the top. And I'll just change the color to red. So now essentially what we've created is we've created this whole row of components which are at 5 volts or high potential, and power line can be dragged anywhere from here. And also we have a row on top for components that we may connect in the upper half of the breadboard. And we have so many places to take a ground wire, and also we have a whole row on top to do this. As you can see, this circuit seems very useful, but we don't need to do this every time we create a new circuit, because as I introduced earlier, there's something called an Arduino starter kit. That already there's an Arduino starter that already has these connections made. So I'll just show you how that is. So I'll just delete all my components now, and yeah, I'll delete my breadboard as well. Yep. So you go ahead here and type in Arduino. So this is where we usually select the Arduino Uno, right? So what you will do is you can just go on this pane, you can just scroll down. As you can see, the starter kit, you have a first starter that basically has the same exact connections that we did just moments ago. So for all future projects, we will be using this starter because this has all the power rails, and the positive and the negative bus is already connected. And yeah, so now I'll just show you how to demonstrate the blinking LED using this breadboard. So I'll just go ahead and take our LED, and you can place the LED anywhere in these terminal lines. So I'll just go ahead and place them. Say I'll just place it over here, I guess. Okay. And now over here, as you can see, this cathode is connected to all of these points in this column, and the anode is connected to all of these points in this column. So the anode must be connected to the two digital pins. So I'll just go ahead and connect it to D10, and the cathode must be and we must remember that the cathode must be connected to the ground, but we must always remember to put in a resistor. So I'll just go ahead and grab a resistor and put it between. So now the resistor is connecting the terminal to the terminal of the resistor is connected to the cathode of the LED, which is connected to the power ground line. So now I'll just go ahead and change the value to 220 ohms as we've done before. And yep, there you go. And now we can just go ahead and simulate our circuit again. Oh, okay, sorry. So we haven't started coding yet, my bad. So we'll just go into the coding pane again. As you can see over here, we've connected the LED to the 10th pin. So all we need to do is just grab the same module that we grabbed before. Select the pin over here. This time the digital input output pin I've used is 10. So I just use the same high pin. And now I'll just start my simulation. As you can see, the LED is glowing, and we don't have an error message because I've connected a 220 ohms resistor. And yeah, I'll just stop this. I'll just stop the simulation. And if you want, and as you can see, I told you that you don't need to know coding. So Arduino, so Tinkercad has this cool feature where if you want to implement this program on an offline setup, so you could just go ahead, drop down menu, click on blocks plus text. So what it does basically is it will just convert all the program that you've done on the blocks. It will convert it to a text. So if you want to implement this, so this is the code that you would be putting in your Arduino IDE to work. So you could just go ahead, copy this, and once you're done with the connections that I've showed you over here, you can just go ahead, copy this, paste it on your file new. I'll just open a new one, and I'll just delete anything there is over here. So I'm just opening a new file, and you could just go ahead and paste this, and you could just upload it, and you just make sure that your Arduino Uno is connected, and your port is recognizing that an Arduino Uno is connected. You just upload it to the code. You should see the LED blinking like we saw on Tinkercad. Now Anish will take up and show you how to implement this in his show you a demo in his ESP32. Okay, and now before that, I will take some doubts. If you guys have any doubts with the connections that I've done here, you guys can drop them in the chat. I will just show the code once again. Yeah, if you guys have any doubts, just put it up in the okay. Yeah, to power the circuit, you just press start simulation on the Tinkercad, and in IRL, when you have the component, you just connect it. You just upload it to your upload it to the board, and as long as you have a power connection, this code will keep running. Hopefully you all could follow. I'll just wait for like a couple of more minutes before Anish will show you the offline setup.
Sir, can you show this figure once more?
I'm sorry, you want me to show the circuit once more?
Yes,
Okay, yeah.
that figure.
This one? Or do you want the slide?
No, you want to see this simulation. I mean, the pic, yeah, this thing, circuit.
Yeah. Okay.
I guess we can start.
Okay, yeah. So I'll stop presenting, and Anish will. Oh, okay. So yeah, okay. Well, I'll just present it again. They're asking how we're gonna get the code. Yeah, 1 second. I'll just show it to them again. Okay. So basically, what we're doing is, so initially we were in the blocks. Interface. So what I'm doing is I'm just going up top over here, clicking on the blocks. So you'll get a drop down menu. So I'll just click on blocks plus text. So what this does is it will just convert the blocks to the C++ program that we need to input on the Arduino IDE. So you can just go ahead and copy that and paste it on your Arduino sketch. You can paste it over here, and you can upload it.
Yeah, you can
Hopefully
pin
that
my
clears it out.
screen.
Okay, yeah. Yeah, Anish has turned on this video, so you guys can just spin the screen. Okay, cool.
Oh, all right. So as we have just seen, this is the breadboard. These are connected to each other, and these are connected to each other. These are the power rails, and these are the terminal rails. So we'll construct the circuit in real life now. So this is the LED. You can see that it has one short pin and one long pin. Long pin is anode and short pin is cathode. So we'll connect the cathode to ground and we'll connect the anode to a digital pin. Okay, so place it in the breadboard. Yeah, you can pierce it gently, it will go inside. All right. Okay, so now, okay, as I said, I'll show you what a jumper wire is. So you can see there are three types of jumper wires. They are called male to male, male to female, and female to female. So okay, this is male to female. One side has a pointed pin-like structure, and other side it's a socket-like structure. Yeah, for Arduino, you have to use this thing. For breadboard also, you'll be using pin-like structure to insert it inside. Yeah, the other one is male to male. It has both sides pin-like structures, and the other one is having both sides socket-like structure. All right. Okay, now as we just done in the Tinkercad, we'll use the same circuit. So okay, this was cathode, this was anode, right? So cathode, connecting it to the ground pin of my uh, microcontroller. So you can see that these are the all the pins in this column are connected. So I can keep it anywhere, here or here or here or here. All are connected. So uh, you can connect this to ground pin on your Arduino. Yeah, you can, people who have kit, you can do it along with me. All right. So I've connected it to ground pin. Okay, and yeah, now we'll connect a resistor. So this is the resistor. I think it's blurry. You cannot see the color coding, but it has a color coding. It is a 220 ohm resistor, which we used just now in the Tinkercad simulation. Okay, and yeah, you have to insert this in the breadboard. Yeah, I'll just show you after inserting. Yeah, and so you can see that they are very delicate, so do it carefully. Yeah, like this. So one terminal is connected to the anode, the other terminal is connected, is in this connection, and this connection will be connecting it to a digital pin. Yeah. Okay, we're connected it to this thing, and this will be connecting it to pin number 10 on your Arduino, digital pin number 10. All right. Okay. Yeah. Then finish. Now just open Arduino IDE where you have copy pasted the code just now. I hope. Yeah. Before that, use your USB cable and connect it again to your PC. Yep. It's lighting up. Yeah. Uh, now we'll start. Yeah. Now we'll start uploading it. Yeah, you can see a right arrow on just the second arrow on the Arduino IDE, which is called upload. Once you connect it, your USB to it, you can upload it. Yeah, it takes a little time. Cross your fingers. Hope it works. That's it. Yep, it's working. Okay, I have used a different code. One sec. Okay, this is blinking LED code. The one in which you use this. All right, 1 second. I'll use the same code. Yeah, it's uploading. Okay, cross your fingers. Yeah, it's working. Yeah, and I can use different LEDs. I use blue LED. Yeah, that's it. Sanjeev, I think you can show them how to blink it now.
Yeah, I'll do it once. Yeah, okay, yeah, okay, so now I'll start sharing my screen again.
Also, if the board starts getting heated up, immediately remove the connection. Okay.
Okay, yeah. So now so now we'll just do the blinking LED project using Tinkercad. I will just share my screen again. Yep. Hopefully my screen is visible. We can just use the same setup. We just need to manipulate them in the code blocks code. Let's just switch back to code blocks. So basically, what we've done here is we've just set the pin 10 to high. So in order for us to make a LED blink, first we need to set it high and then we need to set it low. But if we just keep setting it high and low, it will change very fast because the code it keeps looping very fast, that it will not be visible to our eye. So for that we need to use a control bubble called wait. So this is as you can see, this is pretty self-explanatory and very intuitive. So so basically the first code gets executed, and then when you put this code, it'll wait for 1 second, and you can change it to seconds or milliseconds. So let's just keep it here for second. So this will wait 1 second, and after waiting 1 second, it'll execute the next program. So the next one, what we're going to do is we have to, since we have already set the LED pin high, it will be high for a second. And then let's just go ahead and drag this again. And now I'll just go ahead, select the pin 10 because that is where we've connected our LED. I'll connect it to the pin 10, and then I'll set it to low. So now this should show you the circuit. Now this should and after setting it to low, we need to wait. I want it to be low for 1 second. So I wanted to alternate between high and low with 1 second each. So I'll just go ahead and go to the control pin and bring in another wait statement. And here I'll just wait for 10 seconds. I mean 1 second. So now if I start simulating, this code should work fine. So as you can see, the code blinks. It's turned on for a second and then off for a second and then on for a second. It just keeps on going until you stop the simulation. And let's just go ahead. If you want to try it out on your offline Arduino board, go ahead, click Box and Text. Go ahead and copy this code, and then paste it on your IDE. I'll just go ahead and remove this code. I'll delete this code. And now you can just upload it to the Arduino board, and it should work, and you should be getting the output that Anish got in his simulation. Okay, so now that we're comfortable with using an LED and a resistor, let me introduce a new new component called the power button. I mean, called a push button that that comes with your kit as well, as we explained in the as we just explained a few minutes ago. So just go ahead and click the push button and place it over here. Generally, you place it between the middle, the divider between the upper section and the lower section. This push button, just go ahead and connect it anywhere other than the pins that we've used to connect the LED and the resistor. So so if you want to understand the working, so it's just a switch that closes when it is pressed. So if you're going to get a better intricate understanding, as you can see, there are terminals 1A, 1B, 2A, 2A, and 2B. So the basic concept behind this is that when the button is not pressed, you will have the vertical components will always be connected. So terminal 1A will be connected to terminal 1B, and terminal 2A will be connected to terminal 2B. But when you press the button, the circuit will complete, and so will be completed, and terminals 1 will be connected to terminals 2B and 2A and 2B as well. So the basic objective of a project is now of this project is to start the LED to is for the LED to blink only when the button is being pressed. So that is only when we read an input that the button is being pressed, we need to make sure that this part of the code is being executed. So for that, I'll just show you the basic connection. I'll go ahead and connect the live wire to the terminal 1B. So now terminal 1B, 1A will be high, and I'll go ahead and connect this terminal to the as I've stated before, before using any component, we need to use a resistor. So I'll go ahead and take a resistor for protecting my components from high voltage. I'll go ahead and change high currents. I'll just go ahead and change this to again 220 ohms, the resistor that you have. And yeah, as you can see, the color coding has changed. And now what we need to do is we need to so as you can see over here, the pin will be low as long as this button is not pressed. And as soon as the button is pressed, this circuit will complete, and until these parts 1A, 1B will be connected to 2A. So then you will have all of these ports will become high. So we need to read the value whether this port is high or low. So I'll just go ahead and connect this port to say the third pin, and I don't want it messing with my existing diagram. So I'll just go ahead and change the orientation of the wire to make this more readable. So now let's just go ahead and enter the code and see how this is done. I'll go back to the code blocks editor. So our objective over here is that we need to execute this blinking code only when the LED is being pressed, right? So for that, we need to use something called a conditional statement. For that, the conditional statement you can find over here, if and then. So basically, what we're doing is we need to take an if-else statement. So I'll just go ahead and keep this aside for now. I'll go drag an if-else statement. So basically, what this if-else statement does is that every time we'll give a mathematical condition here. Every time we get a pin, every time the statement is true, the statements over here will get executed, and if it is false, the statements under else will get executed. So before that, we need to first read the value of the input, right? So we need to read the value of the input at the pin 3. So when the value of the input is high at pin 3, we need to make the circuit work. When it is low, we should not make the circuit work. So for that, we will use a variable. I'll just create a variable that says read push. That is basically reading the state of the push button. And you can go ahead and bring this one out. That will set the read push to a value, to a certain value. So I'll just go ahead and and over here, so I need the read push to have the value of the pin D3, right? So for that, we need to take an input pin, and I will go ahead and take read digital pin, and I'll drop it here. So read digital pin, and we've connected the push button to pin 3. So when I change this to pin 3, so this statement essentially means whatever the value of the input at the pin 3 is, assign that to a new variable called read push. So now every time we call read push, we can use it will signify the state of the input at pin 3, at the IO pin in 3, at the IO pin 3. So now what I'll essentially do is I'll once I read this, now I need to check this value. So only if when this value is high, I need to execute this set of codes. So I'll go here. I'll pick up an if else statement, and in the if else statement, as you can see, only a green color block that is in this diamond shape can go in. This is basically a mathematical block for a comparison operator. So I can be like, so over here I'll just go ahead and take a comparison operator and I'll put it here. So what we're essentially doing here is I'll go to the variable, I'll take the value of read push, and I'll go to the control, I'll go to the math, and I'll take the value high. And over here you can change the operation, so you can either compare less than or equal to or not equal to greater than. Over here we want to check if the value of read push is equal to high. So that is what the statement we were using. So we're using a comparison or an arithmetic block from this over here, and we're comparing whether the value of the variable is equal to high. So if the value of the variable is equal to high, let us go ahead and drop it in here. As you can see, this circuit is code blocks is pretty easy to code. It's pretty intuitive. I'll just drag it open here. So over here, as you can see, when read push is equal to high, this circuit will get executed. That is, the pin will get executed. And if it is not equal to high, then we will just go ahead and output set pin 10 to low, because we don't want the LED to do anything, right? So we'll just keep it to low, and we'll set pin 12 to low. And now if we start the simulation, as you can see, you cannot see any output, but over here the push button is interactive. So you go ahead and click on the push button. As you can see, it starts blinking, and when I stop clicking, the LED becomes low. And again, when I start clicking the push button, it starts blinking. So over here we've successfully created this project. So I'll just let you guys understand this code for some time, and if you guys have some doubts, I'll explain it again. You can ask me, you can put them in the chat, and I'll try to explain it. Yeah, so where did you get set read push? So basically, you have 6 panes over here, right? Output, input, notation, control, math, and variables. All of these have inbuilt functions. So I go to variable, and over here I have options to create a variable. And once I create a variable called read push, like I go ahead and type read push over there and click OK, you get 2 variables. You get 2 statements to manipulate the read push. So I just use set. So I just took this over here and I put it here, and I put set read push equal to, and then input, because we want the input from the pin 3, and I put read digital pin 3. So yeah, I'll leave this code for a bit. I'll just give you a couple of minutes to understand this code, and if you have any doubts, you can let me know in the chat. Yeah, Mohammed, the resistor I've used is of 220 ohms. Okay, so if you understand the first statement, then you could just go ahead here And when you go to variables, you will have this bubble called read push. So when you take this out, you can just drag it out and you can put it anywhere. So if I put it here, so this essentially means this will give me the value of read push. So I can put it anywhere in these blocks where the variables value can be used to compare. And I'll put this in the math operator where it will compare. So basically these are all color coded. So if you can see, if you see any purple colored code, it is from this variables pane. If you see, okay, so if you see, okay, this is like, for the light to turn on, you would have to get the connections right, and you would have to press the push button for the light to turn on. Yeah, and Mohammed, please refrain from directly messaging me. You can put them in the normal chat. Yeah, so as I was saying, if you want to know where you get a function from, they're color coded. For example, the third one, for example, this green one, I get it from the math. As you can see, I take a comparison operator and I put it over there, and the yellow ones are control, and the blue ones are output.
Sanjeev,
Yes.
I think it would be better if you like explain the code in C also, like the basics, the setting part and the.
Okay. Okay. Because I felt that this, because we thought that they'll be beginners, so they will not be able to understand the code that easily.
Okay. Yeah. Okay.
Okay, I'll just explain the basics. Or do we have time for that, Anish? Okay, I'll just explain it anyway. Okay. So as you can see, when I click block plus text, so this is the code that you get, that you can print, that you can paste on your Arduino IDE once the sketch, once you've set up the circuit in that way. And now, now going to the code. So over here, as you can see, int read push equal to 0. This statement is equal to, this statement is for initializing a variable. As you know, as you can see, I created a variable called read push. So this just creates a variable called read push and initially assigns it to a value of 0. And later on, we can change it. And so there are two major sections of the code. There's the void setup block and the void loop block. So the void setup block is where it gets executed only once. So it basically lets the Arduino know that which of the pins are being used as input and which of the pins are being used as output. As you can see in this program, we're using pins 10 as the output for the LED, and pin 3 as the input, pin 3 as the input for the push button. So over here it says pin mode 3. So pin mode is the function that we use for setting the pins. And since it's a C++ code, almost all functions should be followed with a semicolon, and input and output should be given in caps because they are should always be given in caps. And yeah, and for most of the functions in Arduino, you will have Arduino functions are case sensitive, so you should, if you want to type this code by yourself, pin mode, like usually when functions with 2 words come, the first letter of the second word would always be capital, not the first letter. So as you can see over here, M is capital. Another inbuilt function, digital write, the W is capital. So now that we're done with the void setup, we've initialized these pins. We've initialized these pins to be the input and the output respectively. Next up we have the void loop. The void loop keeps getting executed as long as the simulation continues until you stop the simulation. Or so over here we're just initializing the variable to the value of the pin from 3. So digital read is the input function. So you will receive, so digital read from 3 is essentially this statement over here. Set read push equal to read digital pin 3. So digital read is a function that you get for you to get the value from any digital IO pin. And over here, as you can see, this if else statement, if statement, the syntax is you need to put the command over here. So this comparison in the green, the math operation is written over here as read push equal to high. We note one thing that we must note here is that we should use a double equal to, because a single equal to will make it a double equal to would be the comparison operator. The single equal to will make it a assignment operator, and it will always be true. And so the if statement will always be true. So if you want to compare two variables or two quantities, you need to always use the double equal to sign for comparing. And the output pins over here set pin 10 to high. The output pins are, so that essentially is this statement, digital write of the pin number that you want to write and what you want to write it to. So I want to write 10 to high. And then the wait function is essentially the delay function. Over here, the argument is given in milliseconds. So 1 second equals 1000 milliseconds. And after that, I would want to execute. After that, I would want the thing to go low. So I would write digital write the same pin 10 low, and again delay of 1000 milliseconds. And after that, in the else over here, this is all pretty intuitive and self-explanatory. And the set pin 10 to low is written as digital write 10 to low, 10 comma low. And now if you want the circuit to work on your, if you have the kit with you, so go ahead. You can always create a new file and rename it, but I'll just be using the same file. I'll just delete everything and I'll paste it. And now you can upload this into your Arduino code. If you have all the connections right, your circuit should work fine. And I'll give you a few minutes before Anish will explain this using his will show you a demonstration using his ESP32. Okay, yeah. Saying that there are no doubts, I think Anish, we can. Or no, okay. Do you want us to move on, or we'll wait for a few more minutes?
Yeah, I guess we can continue now.
Okay, I'll stop presenting.
Okay, spotlight me again. Yeah, all right. I hope you didn't remove the previous setup. Okay. So we'll be adding a new component now. This is a push button. So we can push it. This is a push button. Okay. I'll just connect it. somewhere in the breadboard. All right. Yeah, connect it in the center line. There is a center divider, right? So connect it across the center divider. Yep. All right. So now we'll use the breadboard. So we need to connect LED as well as push button to ground. So what we'll do is we'll uh, use the breadboard now. We'll exploit the usage of breadboard. Okay. So take a jumper pin this type, and then connect the cathode of LED to this pin, this row, the power rail. One of the power rail, you can connect it in this way. Yeah, and you can use another jumper wire and connect it to the same power rail, and you connect this to your Arduino ground pin. So what this basically does is it will connect this pin to ground pin via this. So it is like this. Okay. Now, if you remember, yeah, sorry. All right. So this terminal on the top terminal, we are going to connect it to VCC or the 5 volt on your Arduino. Okay. Now, connect a resistor. Once, yep, it's there. Yeah, connect a resistor from this terminal. All right, to the power rail, because we have to connect it to the ground. So you can connect it to the power rail. Okay. Yeah. Sorry. Yeah, connect it to the power rail so that this will be grounded too. Now take another jumper wire and connect this to digital pin which you used in Tinkercad. You can see the code or connect it to the digital pin which you used in Tinkercad. All right, hope you are done. And yeah, that's it. Now we can upload the code. Yeah, before that, connect it to your USB cable. Yeah, and upload. And it's uploaded. Let's see. Okay, it's not working. Let me check the connections once again. Right. Let me upload it again. Okay. Okay, there seems to be something wrong. Let me check. Did anyone get?
Anish, like
Yeah.
in some of these breadboards, the power lines are divided in between. So like if you on the LED's cathode, can you change the jumper from that end to this right end?
Okay. I mean like this.
Yeah.
Okay. Right. Okay, it's lighting up, but okay, wait, I'll upload the code again. Probably it will work now. Yep, it's working. Yeah, nice. It's working now. So sometimes what happens is the connections become loose, or maybe because of the breadboard connections, or sometimes resistance may become a lot and components may not work. So, okay, nice.
Yeah. Great.
Yeah, okay. I
Any other
wanted to know,
questions?
like, people who people who are having kit, did anyone get this? Like,
Yeah.
if you have tried it, anyone got it? You can put a yes in chat.
Or if people the kit, if you're still trying, also you can put on yes in the chat.
Yeah, we can wait for you.
Okay, so people who are trying it on Tinkercad, can you just put a yes in the chat if you got the code on Tinkercad, it works for you. Okay, yeah, a few people are doing it. Okay, yeah, thank you.
Cool, cool.
Okay. Okay, so now let's move on to our next project. In this project, we'll be using another component that, considering that most of you don't have the kit, and like people with the kit are not trying, I suggest we just stick with Tinkercad. For the next two projects, the buzzer one and the LDR one, I'll just show you how to use it on Tinkercad. Okay, so let me just start by sharing my screen again. Yep, over here, if you want to create a new, we'll just go ahead and create a new project. So on your Tinkercad on the top left, you can see this Tinkercad logo. If you go ahead and click that, you'll go to a new project. 1 second, just give me a second. Okay, yeah. So I'll just click on create new circuit. And yeah, so now as always, let's just go ahead and grab the Arduino starter kit. Go ahead and type Arduino over here, scroll down, get the breadboard starter kit. And so now we're going to be explaining to you how to use the buzzer that you've come with that comes with your kit. It's called a piezo buzzer. So I'll just go ahead and grab it, and I'll drop it, say, over here. Okay. As is with any component, we have to connect the positive terminal to one of the digital pins. But we must always remember to use a resistor. I'll just use a 220 ohms resistor. I'll change it to 220 ohms. 0. All right. And now this terminal is connected to this line. So now I'll just go ahead and connect this power line to, say, the data pin 12. And now we'll just go ahead and connect the negative to the ground. I'll just change the colors. Say, let's just make the circle a little more colorful. Purple. All right. And this is now our circuit is basically done. Let's just go ahead to code blocks. As always, throw this in the trash. Now, now we need to set so go for the output pin, and the code for this is very simple. As you can see, you can find a bubble over here that says play speaker on pin with tone 60 for 1 second. So you can change the tone of the buzzer if you want to. So over here, I'll just go. I want to create sort of a two different tones playing one after the other with a gap in between them, sort of like a siren. So I'll play this tone at pin 12. So since we've connected the buzzer at pin 12, play speaker on pin 12 with tone 60 for 1 second. I'll just leave it at tone 60. You can change it if you want to. And yeah, and then let's go ahead, and we want to wait for 1 second. We just want to play it for 1 second. So we'll wait for 1 second, go ahead and grab it. And then we'll grab another output pin. We want to change. So let's just try switching it up. Not a servo motor. Play speaker on pin and pin 12. And let's just try changing this to like say 80, a tone of 80. And then we'll wait for another second. Now let me just run the circuit. But you guys, wait, was the output audible?
No.
Okay, wait. I think I should enable that in screen sharing. Okay, how do I share the audio on my screen?
Like if you use share tab instead of
All
the
right.
screen, I
Okay,
think you'll get the audio.
I'll share it. Yeah, okay, now I'll try running the circuit. I'll just reduce the volume because it's quite loud. Was it visible now? Was it audible now?
No.
No.
Okay. Oh, okay, now I got it now. Okay, good. Yep, it should be audible now.
Yes.
It is audible, right?
Yep. Yeah.
Okay, so now we've just learned how to use this buzzer, and we saw the code for this as well. Let us look at the text that we will have to paste on the Arduino. As you can see, the code is pretty simple. We're just setting up the pin mode 12 to output, and so there's a special function for the buzzer over here. It is called the tone, which is where you give the pin the buzzer is connected on, the frequency in hertz, and the number of the amount of milliseconds you want to wait. So over here, the tone 60 is the musical key C5, and it will give you a 523 hertz, and and a tone 80 will give you a 1661 hertz. So as you can see, this is the basic code. If you have the setup at home, you could emulate the circuit. Go ahead, paste it on the Arduino IDE and upload it on the circuit, and you would hear the buzzer. I'll just give you some time to understand the circuit, and if you have any doubts in the code, you can ask me. I'll just stop sharing for a second. Saying that there are no doubts. Could people who got it in the Tinkercad just put a yes in the chat? And we'll just go on to our last project. It's called the piezo buzzer. PIEZO. I'll just share the circuit once again. Okay, cool. If you guys have got the circuit to work on Tinkercad, you guys can just put a yes in chat. So C5 and G#6 are the, I would assume they're the musical notes or the tones, or the tones that are represented by the are the tones that are represented in the code blocks. But if you want to change the frequency using hertz, you could always try changing them up in the in your C++ code over here, because the second argument of the tone function is the frequency. So it just alters the frequency. They're just different frequencies.
Yeah, 523 is a hertz frequency, and which is represented by 60. Yeah, in tone.
Okay, if there are no doubts, let's continue.
All right.
All right.
So the next one Anish will be taking.
Yeah, Sanjeev, you have to. Okay. Yeah, I hope you can see my screen. Okay, this is a project we did just now. What we'll do is we'll introduce a new component right now. Okay, we said initially it's called an LDR or a photoresistor. We can use it. We can use it to detect the light. We can detect the light present. How much light is it? Dark? Is it light? We can detect using the photoresistor. All right. So there are two terminals. First terminal, we can connect it to the ground using a resistor. All right. Okay. Now this terminal, what we'll do is we'll connect it to an analog pin, not to a digital pin. We'll be connecting this to a analog pin. Let's say A0. So in the beginning, we said analog pin. Yeah, analog pin is connected to devices whose readings are analog values, who give out analog values. So we'll be connecting it to the analog pin A0. all the 6 pins as input pins are same. Okay, you can use any of them. All right, now let's go on to code block. Okay, like we did for push button, we'll be creating a variable now. I've already created the variable. You can just press create variable and you can type in the variable name. I have named it as light read. Okay, so now we'll set light read to light read. This is a value which we'll get from the photoresistor. It's analog value which we'll get from photoresistor. So what we'll do is we'll read from the pin A0 pin. We have to read it. Okay, so we'll use read analog pin A0. Yeah, as you can see, you can place it in the white circle. Now what happens is light read is equal to read analog pin A0. So it gets set to analog pin, whatever the reading will get from A0 analog pin. All right. Okay, before we use the buzzer, I'll show you one more thing, serial monitor. This is a serial monitor in which we can print the values. Like if you have used coding, there will be a terminal where you use print. The output will be it will be printed in the output will be there in the terminal. Yeah, just like that. For Arduino, it's a serial monitor. This is the toolbar where we can type in and give the inputs to the user. Okay. So what we'll do is we'll first print the we'll put this in the dustbin for now. We'll set it again. Yeah. Where is output? So you can see there is a code block for serial monitor. Okay. Yeah, this is Hello World project. This will be this is the basic project if any. So what we'll do is we'll print the light read, the variable light read in the serial monitor, and let's see what happens now. Wait, I'll show you the text also. As you can see, A0 is configured as input using pin mode. Serial.begin. This is the initializing statement to begin the serial monitor. And this is 9600. This is a baud rate. Yeah, this is light read. Using this, light read is set to analog read A0, and now we are printing it in serial monitor. Serial.println light read. Let's see what happens. Start simulation. All right, it's showing 0. As you can see, you can scroll the value and all right, something wrong. 1 second. Didn't we connect it?
No, Anish, go back to the circuit. Analog read, you're taking. Yeah, no, I think the analog read you're supposed to take. Wait. Okay, show something to them.
Okay, connected.
Okay. You're supposed to connect the other terminal to the ground as well.
Yeah, I've done it.
Right. Then you're supposed to connect this one to the power up to, like terminal 1 connected to power up, and then take the analog read from the after like before the resistor in this one.
Okay. All right. My bad. You mean this, Sanjeev?
No, I think the resistor and the wire should be interchanged. The red color wire, like the resistor should be lower.
Okay. What I'll do is I'll change the circuit.
Change the orientation. Okay, yeah. Hope this should work.
Yep. Sorry, that was a mistake from my side. Now let's start. You can clear the serial monitor before. Yeah, as you can see, it is showing 6. The value which is red is 6, and it is at the leftmost position. Okay, different values have different photoresistors have different values. And also in real life there will be some resistance, extra resistance, and they don't work perfectly. So yeah, now we know 6 is dark and 679 is light, fully light. So what we'll do is, with the help of this, we'll create a machine where if the room gets dark, the buzzer will start ringing. All right. What we'll do is use an if statement now. If math all right. So what I'm doing is, if the variable light read, the variable which is reading analog pin, the variable light read is less than or equal to, let's say, okay, we'll put it as 6. Then the buzzer should start singing. If the light read less than or equal to 6, then the buzzer should start ringing. So we'll use the same code as last time. All right. So if the light read value is less than or equal to 6, then the buzzer will start ringing. Let's see the code. Yeah. Less than or equal to 6, the buzzer starts ringing. All right. Let's start simulation and check it.
Yeah, Anish, we can't hear anything. So it's like,
Yeah.
so just while you're sharing, like when like stop sharing for a second.
Once.
And when you try to share your screen, like when you select screen or something, on the bottom left of the share screen panel, there'll be a share sound.
Share
option.
sound.
Just
Yeah.
Just check it.
All right. Now let's start. So when it is at, so you can see when it is at leftmost position, the buzzer starts ringing. Once we move it, it stops. We'll move it again. Yeah. So that's how it works. You can see the serial monitor too. It is at 574 now. We can change it. Okay, it's too noisy. Oops, sorry. Yeah, you can complete the circuit.
Mohammed Bakir, I think this session is being live streamed on YouTube, so I think you can find the recording there. Okay, yeah. So one thing we should note that is that this circuit must be connected in this way, because when the LDR is connected after the resistor, then it would be pointless, because after the resistor you anyway connected to the ground pin, so it would always output 0. Always the analog output would be 0. So hence we must connect it between the resistor and the LDR for us to notice the change in the values.
Yeah.
Yeah. So the outcome from this session, that I think that is our last project. So the outcome from the session that we had in mind was to introduce everybody to basic Arduino coding, and probably and hopefully you guys have now got an idea how powerful Arduino is, how powerful the platform is, and how if you have the right sensors and the right idea, you can possibly create any circuit, you could possibly solve problems in your own life. So it's basically so if you want say the buzzer to ring when the water is full, you could have a sensor for that, and you can type on your own code. So what we're trying to show here is, if you have the Arduino board, it is basically a canvas for creative people to come up with their own projects. So that is so we hope that would be a takeaway from the session. And yeah. Yeah, if you guys have any other doubts about this project, you could ask us.
Sir, my Arduino is not working in my laptop Ubuntu operating system.
Okay, did you try the links which I shared in the chat?
Yes.
Okay. Okay, that part like we'll discuss in the WhatsApp group for working out the driver, any issues with the driver. Okay.
Yeah, doubts regarding other microcontrollers, you could ask this separately.
The LED is glowing.
Okay, then I think the Nano would be working fine only, right? Only some driver issue, right, Sanjay?
Yeah. If the LED power LED is working, then you should just go ahead and look up the schematic for the Nano and try to program it accordingly. Because the schematic states, like, you need to look at the digital input output pins, you need to look at the analog input output pins, and And I think if you just look into the schematics, then it would work.
POW LED is blinking. POW LED is glowing.
Yeah.
But no
Okay.
notification.
Yeah, that is the power LED. So that means that
Yes.
your nano is receiving power. Uh,
Okay. Any other doubts other than that? Like, how many of you did the project on Tinkercad? Like, put maybe some yes or any doubts? Okay.
Yeah, with regards to Arduino Nano, you can find the other guides online, and if you're unable to, you could just ping us on the WhatsApp group. We'll let you know. If anybody else has any of the doubts regarding the projects that we did on Tinkercad right now, you guys can ask them, or else I think we'll wrap. Thank you for attending. Thank you on behalf of Electronics Club and SQIL.
Okay, thank you, Sanjeev and Anish, for sharing their valuable time for us. So I hope like everyone understood what an Arduino is and what all are the basics. So in tomorrow's and day after tomorrow's session, like we'll be discussing more advanced topics and more sensors and the codes with Arduino. And like later on the day 3 or in day 3, we'll be working on a full project, and that will guide you in preparing in more advanced projects. So like thank you all for joining in day 1, and I hope to see you all tomorrow.
Yeah, thank you for attending. Don't forget to attend our session tomorrow.
Yeah, thanks a lot for attending. It was fun. Hope you all show the N2 tomorrow too. Yeah, and I posted a GitHub link which will be shared to you, I guess, in WhatsApp group. You can find all the codes and Tinkercad simulation there. You can use it.
So thank you all.
Yeah, thank you.
Thank
And
you.
for those who don't know how to use GitHub, like use the link, and then like they'll be shown in different pages, different files called with the extension .md. So if you click that, you will get the necessary codes, right?
Yeah.
Okay.
Just click on the link and click on the project link. You'll be open the page. There will be a code, schematics, and Tinkercad simulation link too. You can use it.
Thank you, Anish. Okay, like see you soon tomorrow. Okay, that wraps our session on day 1. Okay, thank you all.
Yeah, thank you.
Bye.
Yeah,
Bye.
thank you. Bye.
Bye. I think we can stop streaming, right?
You guys can let me ask the host to stop the streaming.
Okay. Yeah. Thank you for attending. Thank you for this opportunity.
Bye.